Electrical outlets, another big one. Here's some examples of some airtight boxes. There's other ways to achieve air tightness around the boxes, but we'll get into that later. Knee walls between flat and vaulted ceiling details. A lot of times there's not, actually this is a interior wall from the attic side coming down a wall, an interior wall in a building.
So this is a case of air leaking between the insulation and the air barrier. So the drywall is the air barrier, but the cold air is getting, there's just bats up against that back of that knee wall, and so the cold air is just leaking between them, which makes the insulation pretty much useless.
Using gaskets and foam sealants are a way to stop that. Fireplaces are a big one where they don't get detailed very well. These are all things that are part of the code and we're going to be going into in more detail later, but these are just kind of the big ones that we see a lot. Doing a proper insulation and air sealing details before the fireplace gets installed on the walls, the floor, and capping a chase if there's a vent that goes up.
This one's a little hard to understand, but it's actually underneath a cantilevered floor, and this warm area is the heat leaking out because there's no air barrier where that floor cantilevers out over a foundation.
And then this is just an image of a good air sealing detail for a cantilevered floor.
That's a top plate. Actually, this is in this building, and they can get away with this. This is looking down at a top plate. This is a truss. You can see the gaps either side of the top plate. This is a place that we see a lot of air leakage. They got away with it in this building because they actually insulated the whole of the underside of the roof. So the attic doesn't have blown-in insulation. But what should happen before, and this is a recessed can up in this attic too, and you can see, I mean, the whole attic up there is lit from the light leaking out of the recessed cans. And so you can imagine if you just blew insulation over the top of that, how much heat. And a thing to remember is that insulation doesn't stop air movement. That's a really key point. A lot of people think that insulation stops air movement. It doesn't. It slows heat movement, but it does almost nothing for stopping air movement. And so just sticking a bat over this, which we see a lot, or fiberglass, or just blowing in some fiberglass insulation, doesn't stop any of that heat that's going to leak out of that thing. So what should happen before insulation gets blown in this attic is that all of those things get sealed up.
This is a top plate right here getting foamed. Recessed boxes, foam boxes going over the tops of the recessed can lights. This particular project had a lot of recessed cans. The reason that the boxes go over the top rather than just spraying right over the top of the can is that the can will overheat. So there has to be an airspace provided so that the cans don't overheat. Here's a couple good examples of missing top plate here. You can see that they furred this wall out, fiberglass insulation, but they didn't put any top plate in there. So air is just going to drop right here, come right from the attic and leak right down that wall. Here's a good example of...
this just brings up another point is to think about is that each piece of cavity insulation should be enclosed on 6 sides. So front, back, top, bottom, and both sides. Okay? So a knee wall is a good example. You're up in an attic, you've got a framed wall, you've got drywall. If you just stick a fiberglass bat in there, and oftentimes knee walls you don't have a top plate on them, change the way you do things. Put a top plate on it, you've got drywall on one side and you need to have an air barrier on the back side as well, so that each piece of insulation is enclosed on all 6 sides. Obviously, blown insulation in an attic is a different situation, but all cavity insulation should be enclosed on all 6 sides.